Our project is a water filtration system that is designed for those who don't have access to electricity or clean water. We will be dropping 10 pounds of potato bag at 2 meters high to generate kinetic energy from potential energy.
For the manufacturing portion of our project, we decided to order 3 components that include the Acme threaded screw, the Acme threaded nut, and the force constant spring. The parts we made ourselves include the cap and pulley, which is designed to house the force constant spring and suspend the mass, and the stand, which is going to be holding up our entire project on top of tables.
So in the analysis of our design, we did multiple calculations. So I'll take you through them right now. And the first calculation we did was to find the minimum length of the pipe. And we found out that it was 0.0877 meters. Then we found the force in the screw, and which we found out to be 39.6 newtons. Then we found the spring efficiency, which turned out to be 89%. And we used an equation to find the pressure drop in the pipe we were using, the PVC pipe, and it turned out to be 1.9 pascals, which is really small. Then we found the pressure drop across the filter. We used this equation over here, and we found out the pressure drop across the filter we have is 0.01 pascals. So we used all of the previous equations to find out how long it takes to fill a cup. So we found the exit velocity using the Bernoulli's equation. It turned out to be 0.305 seconds taken to fill out a 400 milliliter bottle. And finally, we found the efficiency of the filter system. We found it to be around 97%.
The simulation on our projects were done on the inner walls of the PVC pipe which would hold the water in the tank. Using a hoop stress formula, we were able to find that the inner walls of the pipe would experience a pressure of 8,600 pascals. Our PVC pipe is designed to hold a maximum pressure of 52 megapascals. This ensures that our pipe would hold the pressure during the testing phase. Using SolidWorks, we were able to simulate the internal pressure on the PVC pipe. As you can see here, that the maximum pressure experienced by the inner walls of the PVC pipe is around 13 kilopascals. And our material can hold a maximum pressure of 52 megapascals. This ensures that our PVC pipe will work normally during our testing and simulation phases.
The Acme threaded screw we purchased has a lead of 5 millimeters. This essentially allows the nut to travel further in comparison to other threaded screws. The nut is then welded onto one end of the force constant spring, and the force constant spring is attached to the inner diameter of the cap. The stand we made out of composite wood and cut a hole for the cap assembly to hang over and added supports for the screw to pass through.
The system we built will be filtering water by converting vertical motion to lateral using gravitational potential energy. A 10-pound potato sack suspended at 2 meters will be attached by a rope to the cap that will be turning a force constant spring. Water will be inserted into the tank by the use of a funnel, and a hole is drilled into the tank to allow for the insertion of the funnel tip. As the weight is dropped, the spring will be pulled and compressed in the same rotational direction as the cap. The spring is welded to a nut which turns the Acme threaded rod when the cap is held stationary. Afterwards, the spring will have enough energy to rotate along with the nut and push the threaded rod. As the rod turns, it will move towards the plunger that's enclosed within a pipe which is attached to an elbow where water will be coming out. The filter is attached at the end of the pipe and at the beginning of the elbow so it can receive the water that needs filtration. The process can be repeated many times as required, although we do advise of changing the filter after a couple uses. It's possible to hold the energy for an hour using the force constant spring in our design, but since we don't have a stopping mechanism, using our hand to hold the threaded rod in place will suffice.